Alright, today I'm going to show you how to use NeuroRobotics Studio to make the Boston Dynamics Spot Robot walk. So, to get started, we're going to open up NeuroRobotics Studio, and you'll see a page like this. Click on the Embodiment Explorer, and then select MuJoCo Physics Simulator. You're going to click on the Boston Dynamics Spot Robot and hit Explore. You'll see here that I've not installed the MuJoCo controller, so now you'll need to install it before you can open the embodiment. Alright, this might take 1 to 2 minutes to get installed, but once it's installed, you can launch the experiment. For this experiment, I'm going to use the default Boston Dynamics Spot genome, but if you want to start from scratch, you can use an agnostic genome, or if you already have something built, you can preload your own genome. So I'm going to launch the experiment. When the experiment loads, you'll see 2 tabs open. One will be the MuJoCo simulator, and you'll see the Spot robot, and then you'll also see the brain visualizer. You'll see that the Spot robot does not do anything when it's loaded because we have to build the brain for it to give it movement controls and logic and, all of the things that we want it to do. This tutorial is going to focus on central pattern generators. What central pattern generators are in nature is a neural cluster, like a neural circuit that lives in our spine that helps with, repeated movements like walking or, like any kind of rhythmic movement. So we are going to give this dog a brain and build a central pattern generator for the Spot robot. So to get started, we're going to build a new circuit, and we are going to give it a name along the lines of cycle or loop. Basically, the logic that's going to live inside of the circuit is just a really simple looping cortical area that will then attach other areas to give more complex movements. This is the base of the central pattern generator. I'm going to name mine loop. Once you've created your circuit, click it and then open it in a 3D viewer. This will open up the circuit builder and the brain monitor. Within the brain monitor, we're going to give it a new interconnected area named something like cycle. So the dimensions of this area are going to be the amount of steps that we want our looping behavior to have. So mine will have 4 different like movement gates. So I'm going to make it 4 long and then 1 tall and 1, deep. So whenever you're happy with the area, create it. So you can see that this area doesn't do anything on creation. We have to define some rules to give it the behavior that is desired. So click it and then click on View Cortical Area Details. Inside of the Connections tab, we're going to add a recursive rule. So because I made mine 4 long on the x-axis, I'm going to use the lateral plus x rule. If you made yours longer along the z or y-axis, then choose the relative rule. Once you've given it the lateral plus whatever axis you made it, long for, then you can give it a last to first rule. So these are the 2 rules that will control the repeated looping, signal that propagates through the area. But to demonstrate what each one of these rules are doing, I'm going to remove last to first. So with just the lateral plus x rule, when I hit space after shift clicking on a neuron within the cycle area, I can see that signal propagate through. When it reaches the end of the area, it dissipates, however, and I want it to, recursively infinitely loop. So what I'm going to do is add another rule called last to first, and I'm going to set that mapping. What the last to first rule will do is when it reaches the highest number within, the vectors that are available within the area, it'll send it back to the lowest value. So now if I hit space, we can see that it infinitely loops. This is the basis of all central pattern generators that I'm going to be building. So off of this circuit, we're going to create another circuit that will then define the actual, movement rules that we want the robot dog to follow. If you don't feel like building your own loop circuit, I made one available in the Brain Hub. So in NeuroRobotics Studio, you can click on Brain Hub, and then you can search by my name, or you can search by a genome named loop. So you can look at obi and loop, and then you can select it and import it into your own project. It is the exact same circuit that we just built right here. So you'll see that even though we have a signal propagating through the cycle area, the spot robot is not reacting. This is because we are yet to tie any motor commands to this looping behavior. So what I'm going to do is create a new circuit titled like CPG for spot. And I'm going to create it. Then we're going to expand this into the 3D viewer, and we're going to add some areas within the brain monitor. So my project will use 3 different gate areas, but it will repeat one of the rules twice. So I'll explain this as I'm doing it, but I'm only going to create 3 1x1 areas named G1, G2, and reset. These will vary based on your needs. So if your project has, a different number of steps that it needs to take or a different behavior, your, central pattern generator will look different than mine. So if you look at the lower left of the main brain visualizer tab, you'll see an area called body 0 or some similar output area for whatever embodiment you're trying to build for. So clicking Control 2 and then clicking on a neuron within that area will snap me to the axis that I want to be on to view it directly. I just find this to be the easiest way to map specific neurons to set rules. So I'm going to start by mapping the reset area to specific neurons within the body block. So I clicked on map entire cortical area to specific neurons. And then I'm going to choose the neurons within the body block that I want to activate. So one thing that I'd like to point out is when your cortical area is an even number of neurons, wide, you can't get an exact 50% by choosing the middle line. If it's odd, there will be a middle line, and that usually will hold values of like 50%. So what I like to do is select the entire top row and the entire bottom row, and these values will average. So if I now shift click on reset and hit space, the robot dog will go back to its initial position, which is just valuable because when you hit reset in MuJoCo sim, if your controller is reading some position, it might not reset correctly. So having a cortical area that's tied to actually reset all of the motor values of whatever embodiment you're using can be really handy. I will also be using the reset in the central pattern generator that I'm building. So these 2 gates, G1 and G2 that I've made, will actually have a few connectivity rules within them. These connectivity rules I'll now show on screen. If you're following along with this tutorial, you can copy them into your project, but I am just going to fill these all out and then overview them when I'm done. So one thing that I wanted to go over about the central pattern generators is the movement gates that I'm creating. So I'm creating 3 distinct movement gates that will be responsible for different positions of the robot. So the reset movement gate, which I already talked about, will just be the default position of the robot's legs. So just standing as straight as possible. So the other gates, gate 1, will move 2 of the legs to a fully extended position, and the other 2 legs will maintain their original position. And then gate 2 will take the other legs and move them forward, and then move the legs that were just extended back to their default position. So the idea here is that we're alternating the legs so that the cycles will go G1 to reset, to G2 to reset, and then back to G1. So this loop will infinitely cycle the different walking positions. So now that we've established all of our connectivity rules for our gates within our central pattern generator, we will now need to connect them to the looping, cycle area. So to do this, open up the loop circuit within the brain monitor and zoom in on your cycle area. Then in the main brain monitor, make sure that you can see all of your central pattern generator areas, and we will be connecting these in the sequence that we want to the cycle area. So here, I'll show you how that's done. In cycle, select the connectivity rule of mapping a specific neuron block to an entire cortical area, and then select the first position of the cycle area. Select the destination that you want. For me, this is going to be G1, and then establish the connection. Repeat this step through the remaining areas of the cycle area, and make sure that you're doing it in the sequence of the behaviors that you want. So for me, it's G1, reset, G2, reset, and then the loop repeats. So keep that in mind. Once you've established all your connections, I want to point out an important setting, which is PSP uniformity. Make sure this is turned on for all of your areas within the central pattern generator and also for your cycle node. What PSP uniformity does is it takes an outgoing signal from one node, and if PSP uniformity is not turned on, that signal will be divided to the number of neurons that it is sent to. So if you have a signal of 1 that's sent to, 3 neurons, that signal becomes 0.33 repeating. And if you turn on PSP uniformity, if you're sending a signal of 1 to 3 areas, to 3 neurons, then that signal remains 1. So this is important for, trigger thresholds and a bunch of other things. Once you've adjusted those settings and connected your central pattern generator to your looping area, we should be able to see Spot actually walk. In testing this, make sure that your refresh rate is set lower than 500. I'm going to set mine to 5 for debugging, and then probably somewhere around 10 or 20 for actually running the project. Let's test out the central pattern generator that we just built for the Spot robot. So we can see that as the signal propagates through the loop and activates the different areas within the central pattern generator, the Spot robot begins to walk. So because the refresh rate's currently set to 5, this movement is slow and a bit choppy, but setting it to a refresh rate of 10 or 20 will make the movement a lot smoother and faster. Alright, I hope you enjoyed this tutorial, and if you made your own project using a different embodiment or even the Spot robot, feel free to share it in our Discord. Alright, thanks very much for watching. Bye.